Hello guys, welcome back to this channel. Today we have a couple of things we're gonna do. Then I'm gonna show you the analog. Now last time I did digital. Today I'm gonna show you analog, and I have a couple of things here. This is LED. This is a resistor that I used in the other experiment. These are two jumper wires. This is a USB which I have to use to connect to the Arduino Uno. Sorry guys, the camera has to keep moving because I'm holding it in my hand. This is the Arduino that I used, Arduino Uno. And then for this experiment, we have a breadboard. And then you have the computer there, and the light there. Yeah guys, so good morning. Maybe I have to test the LED to know whether the LED is working properly first of all before I can engage in this video. Guys, I have to be careful because this thing can fall to the other side. So I'm gonna check the LED. I hope you are seeing me well. Yeah, you don't mind seeing my face or not seeing it. So I'm gonna use this cell to test whether the LED is okay. Oh, this thing is in the habit of falling down. Sorry guys. No. Seems that the LED is not working properly. Which is a positive and negative, I don't know here. Oh, come on. Oh, maybe I have taken the wrong cell. One or two cells here. One cell is, I don't think it's working. Let me see this one. What the hell is going on? Maybe the LED is not okay. I don't know what is the problem. So guys, just excuse me. I'm trying to find the cell. Don't know where. There's another cell here. You know, in life it's very funny that you have to keep stumbling on the wrong ones first before you stumble on the right one. Even this one is the wrong one. Yeah, you can see it's on. You see the red light? So I'm testing to know whether this LED is okay. Hello guys, once again, welcome back to this channel. I go by the name Victoria in YouTube. That's my channel's name, and I'm happy this morning. As I woken up, I thought, why not put up a video for you? Because last time I had shown you the digital. Let me get something to quench my throat. I think my throat is always heavy. I made strong. I'm a fan of strong tea. Feels nice. Yet another day God has given us, fresh day. We give thanks to the Creator. So what are we gonna do today? We're gonna connect this analog and see how Arduino fits analog signals. And what's the difference actually between analog and digital? If you're watching this video, I expect you to know. Digital are zeros and ones, and it's not continuous, it's discrete. Analog is continuous. Always. Always. So there is this thing. This is analog, it goes continuous, you know. The digital, I don't have a pen, around. I'm sorry I didn't write, but digital is not continuous, let me say so. That's a different topic altogether from what I want to do. And since I'm using this LED in engineering is represented by this symbol, this means that it emits photons, which is within our spectrum range, where we can see LED and the diodes are same, but the diode, the photons that it emits, we can't see because the frequency range of it falls below our visibility range, and is below, like what we are seeing from the LED is between 400 to 700 nanometers range. That's the visibility range, and the diode will fall below that, maybe go to 0.01 centimeter, or that's infrared, or 1000 nanometer. I'm trying to see below that range. The photons that it emits we can't see with the human eye, because we have a specific range. We see, we have the microwave, we have the radio waves, microwave, radio waves, we have the ultraviolet, we have infrared, we have visible light, we have the X-ray and the gamma rays. There's the 7 waves that exist, but we only see light. So we're gonna perform this experiment, and I don't think there's much for me, because if you don't know anything about LED, I have done the previous video. You can go back there and watch one of my videos where I extensively cover what LEDs are. In short, it means light emitting diode. They use the LEDs and diodes to use the same principle. They both emit photons, except only LEDs emit photons in the range visible to our human eyes, right? We are not covering range of waves. We are doing an experiment for Arduino to determine how Arduino can read analog signals. Already I've told you what an Arduino is: Atmega 328 microcontroller, an open-end software and hardware which can be configured to do anything. To do Wi-Fi, to connect motors, sensors, and so on. This thing, as tiny as it looks, so powerful. This is a port. So I'm taking this up and I'm gonna show you what I'm doing. I'm connecting it here like this. I have to be careful not to remove this thing from here. So now I've done that. Here I'm going to connect to a computer port. Okay. So from this time on, guys, I'm going to turn this camera. So now we'll just focus on the experiment itself. Okay, let's go. I'm turning the camera. This thing stopped suddenly. This camera also is a smartwatch camera, so sometimes it has its own shortcomings. I hope that I'll be able to reconnect these two things. Or I may put 15 and 20 because they're near each other, or rather I put 10 and 15. Okay, let me put 10 and 15. Maybe I should put 15 first. I think 15 and 20 is okay. 15 and 10, right? Yeah, man. 15 and 10. You see what I'm doing? I've connected 10 and 15. So we are going to measure these voltages here, analogs, and we're going to connect this LED across this area of separation here. The two are not connected. This is like a trench, like separation between this and this. So I'm connecting the long leg of the LED here, and the short will come across here. So let me do it. You go, guys, I don't want to go wrong. Actually, sometimes these things can be a really hassle, headache. I have to be careful. I'm using one hand. The other one is holding the camera, so it's quite technical. Let me see. Okay, I managed. You can see I've connected long leg to this LED here, short leg here, and this one I'm connecting now to the ground. First of all, let me connect this to pin. To which pin now? You know, these pins in the Arduino, the ones that have a line, like squiggling line, I can name them. They are like, we have 5. Well, where's my lens? So I need to have a lens to see. 5, 6, 3 also, and we have 9, 10, and 11. So any of this we can connect pin 10 or pin 9. Let's connect pin 10. Let me see. 1, 2, 3. 3 from up. Okay. So 3 from up means we have to count 3 from up, and let me see. Pin 10. 1, 2, 3. From down, 3. 3 from down. So I count this here in the Arduino. I count 1, 2, 3. There now I'm pin 10. I counted 3 from this point. From this point, I counted 3 that way. Then I reached 10. I put there because 10 has a squiggly line. Let me check again so that I don't make a mistake. Yeah, pin 10 has a squiggly line. That's a pin that we're going to connect. We already connected to pin 10. And then I'm going to connect this shorter leg of the LED, this one, to the ground in the Arduino. So I'm connected here. I told you they are vertically same, connected. I have to be careful. If I shake the camera like this, it might stop. 1, 2, 3. The fourth one, I think, will be the ground. You are not wrong. I'd counted that before. Let me check again. Yeah. 1, 2, 3. The fourth one. 1, 2, 3. The fourth one is the ground. So I'll connect these pins. Now you see. Now we are ready to perform the experiment. There is the machine itself. Now what you have to do here, you have to download the Arduino. You go to Google Chrome, and I don't know whether the camera is recording. You know, technology is something we have to grapple with. So here you can see where the cursor is going, the computer there. I've downloaded Arduino there. You go to Google Chrome and you download Arduino. Then you can be able to do this experiment. Now you can see Arduino is setting on. It does like that, infinity thing, minus plus. This simple comes like that simple, which is not infinite rather, but looks like something like that. Arduino is setting up. Well, meanwhile, let me try to do one thing. Sorry guys, I hope you are following everything right. Anyway, we are waiting for Arduino to settle. I have to check some stuff. I don't know where I did this thing. I don't know why it's taking too long. Yeah. Today something's wrong. Yeah, it's there. You can see it has put some code there. Maybe let me turn the camera a bit. I don't want to shake this thing because it comes off. It can just cut off. You see, the code is there. Somebody told me that the camera of the phone can get damaged when I'm putting against that light of the computer. You see. Now we are going to go to File. Okay, you see where the cursor is moving. If you ever know anything, guys, if you are from the street, it might be difficult for you to follow this. I hope you have some background in this. I click there. Then I come to examples. I go to the basics and the bare minimum, which I click there. You can follow the cursor. I clicked there. I make it so simple that anybody can do it, even somebody who is cleaning the street, who has never known anything about this thing called Arduino, can program it. Actually, it's easy to program a microcontroller, as I showed you from the previous video. Now I've done that already. Now you see it has brought this screen where you can see the cursor. Why is the cursor here? You see that? It doesn't really seem visible. You can see the cursor. Now I'm going to tools up there, and I'm clicking the tools. Okay, it brings that menu where I come to the board, because I have to set the board. It's a Arduino board. You can see what I'm doing. I'm going up to Arduino. Okay, I've clicked Arduino board. Now it's here. You can see it here. And then I'm going back again to set the port. Arduino port is here. COM3. Now I've set both. So from this point on, I have to program this thing. Now what I have to do here, because I don't know how I can really be able to slot this. Yes, that's exactly at point 1. So I'm going to press enter. Recopy, void setup, void setup. The whole idea is that I have to delete the one above so that I can declare a variable there. Void setup, parentheses I put there. You can see parentheses, and then I have the curly brace. Okay, because I'm gonna delete one of them, just like what is above there. The whole idea is that I'm going to delete this so that I can declare a variable here, because you are dealing with integer, and the integer is a constant which is not required here. So I'm going to declare a variable, because we are doing analog, not digital. Int, I can call it green pin, for example. Green, I'm writing there, guys, green pin. P is capital, the rest is lowercase. Pin, and then I'm putting equals to. I'm going to initialize it to 10. I gave it 10, pin 10, right? And I put that semicolon. I think I'm gonna declare everything here. Okay, let me go down first. Where is written, put your setup code here, which runs only once. So here we have to put pin mode. So we're gonna put pin mode. Pin, M is capital, mode, just one thing you write like that. Pin mode, then put the parenthesis, and once you put the parenthesis, you write red pin or green pin or yellow pin, whichever pin you declared up there. Whatever variable you gave is what you write here. So we declared green pin, put a comma. It's gonna be an output, right? Yeah, because we are sending a signal to pin 10, output. So now I read an output, and then of course we're gonna put colon. Don't miss to put a colon. After we have done that, now we're coming down. Okay, we're coming down to this end. We're going to send to now run the code itself. Here they say put your main code here to run repeatedly. Okay, it's given this message here. You can read it. I don't know whether you are seeing it. To run repeatedly. Sorry, sometimes I forget, guys, the camera that you have, because you are following. You see now, you can see what I've written. Int green pins equal to 10. Void setup. Then pin mode green pin slash output. Down there now I'm writing analog. I'll show you in a minute. Sorry, it's supposed to be small letters. Analog write. W is capital, write, analog write. And what you are going to write, put the parenthesis, and then you put what? Green pin, which we declared up there, that variable. Green, P is a capital, pin, green pin, comma, 255. But actually we don't put the constants here, so we're gonna declare another variable, because constants are not a good practice. So you know, basically we are dealing with 0 volt up to 5 volts. Now 5 volt is equivalent to 255, because we are dealing binary, which is 1 0 1 2 4 8 16 32 64 128 256. But since we are counting from 0, so we put 255, which you are seeing there. We don't put 256 because we start counting from 0 in binary bits. Okay, and now because let's declare another constant here, because variable. You know what's a variable? Int is an integer because it's a number, so that's why you use int. And what we're gonna, you can write anything, but for me I'm going to say light, int light is equals to, initialize it to this value, so the computer will be able to pick it up. And then down here, instead of writing 255 here, I'm gonna cancel this one, right? I don't know why it's not coming here. So sorry, some noise will come from outside, guys, you don't mind it. Here, I'm canceling that. And see what I'm doing? I declared a variable there. I have to be careful not to dismantle this thing. You see, 255 I declared, and I given it the variable light. So down here I'm going to put this variable light. Unlike the other one where we have to put in teacher, we put high or low. Here we don't do that. We do quite differently, you know, not the same. Now the code is ready. You can see it once again. I've declared int green is an integer. I've given the variable green pin and I've initialized the value to 10, pin 10, which has a squiggly line in the Arduino. I showed you that. Now int light, again the value 255, which is equivalent to 5 volts. And in the binary setup, because it is 240 1248 like that up to 256, but since we start counting from 0, we write 255 up there. So we're done with that one, void set there. Now down here where we have the void loop, we have put analog right green pin. Let me see. Oh man, what did I write even? The spelling is wrong. Here I wrote it's supposed to be green. Green pin light. Okay. Analog right. Now it's correct. So I put this stuff. Now we are going to upload this to the Arduino, to this thing down here. This thing is called Arduino. And I want you guys to watch this particular thing, this one. This is just to show you that power is running. But the pin that we are concerned with is this one. Watch this, what happens when I upload this. Somebody singing from outside, guy. I think it's part of the video. Okay, now let's go. Watch the cursor where it's going. You see where I put the cursor? There is, this button is for uploading. So now I hit the button. I've hit the button. Okay. Now watch down here what happens if it's successful. Sorry guys, an error has occurred. Grain. Where is the grain? This thing is also another problem. Now I just wrote it once and it's saying that it's wrong. Let me rewrite it again. Shit. Yeah, cockroach is running on my hand. Green. It is not seeing that I'm alive, or it thinks I'm just a dead wood. Green pin. Right? Oh, I can see where the problem is actually. The problem is here. Yeah, I misspelled this word here. See, I wrote grain. G-R-R instead of G-E-E. Now the correct spelling is there. I rewritten it once and you can check it again. Int green pin, int light. Okay, that's correct. Down here we have written analog right green pin is light. The variable that we globally declared up there will apply here in the void loop. Now we are running the code again. We are uploading it. So I put the cursor there. I'm gonna hit this button and I want you to watch this button where my finger is pointing. What will happen? Right? This one. Okay, let's try again. So there I hit that button. There I hit the button. So we watch here. Okay, successful. You saw it blinking. Done uploading. Now we can change this light to any figure. For example, let me less it or make it more. Let me give it a value like 120 up there. You see what I'm doing? I'm writing half of that is 120. Let's say 120. 120. Make the value less. And you see how bright this LED will be. This LED. Now check again. I'm uploading. You check the microcontroller where my finger is pointing. You check it. What happens with the light, the intensity of light. Okay, you see? It comes dim, but still you can see it's dim but not very dim. I want to put a value that will really not show at all, something like 10. Okay, you just watch the Arduino. So I'm uploading there again. There, I hit the upload. Here, see the cursor? Here, this thing. This is for upload button. There, I hit it. Then watch here. Okay. You see, the thing is that let me put 0 value. I see what happens. And let me upload it again. It's like this thing wants you to rewrite the code all the time. Now it's off and on. So analog, unlike digital, comes on. It shows that and comes on. Yeah, man. Int light. Pin 10. Int light. Pin mode is green pin. Output. Right. Analog right, green pin. Light. Int. I just put 0 here. It is still showing. Let me put 10. Let me upload again, once again. You can see how, okay, it goes off and on. I don't know what's wrong with the, oh, yeah, I see where I'm doing a mistake. Sorry guys, we are supposed to check the LED, not check the Arduino. We are checking the Arduino. Arduino, once it blinks, it means that we have successfully uploaded. Now let me put totally 0 again, like I did before. Let me put 0. I'm sorry that I was just focused on the microcontroller and not the breadboard. The main experiment is here. You watch the LED, the amount of light that goes there. Now upload again. I hit the upload button and watch here. The LED, this thing is totally off, you see. Now if we increase this reading to maybe 10, because it was 10 before, let me put it around 20. Okay, I have put it 20. You can see there, guys. Int light is equal to 20, the intensity of light. And then I hit the upload button and you watch here. Now it's totally off. There's a cockroach which is also competing with space here. Okay, there we go. I hit this button again. You watch here what happens to the LED. The extent of intensity of light will determine how much of the lighting will be. You see, the LED light dimly. And we are successfully uploading. Now let's take this value to 100, for example. Okay, add 10 here. The value has gone up. You can see is I put 100 int. This variable which is called light. You can declare anything here, but for me I put light. You can say sick, laugh, smile, whatever int you declare. So long as you initialize it, the computer is going to output whatever you input. So you input this, it's going to output it. So now you can see this is how dim the LED is here. You can see the LED is very dim. Now it's gonna, we have increased the resolution, the intensity. Now let's go. You see, watch what happens. Okay, you see it's becoming more brighter. You see it's becoming more bright. Now let's give it the value that you can actually see something like 250 double data. That we say 250. I've written it there. You can see I've changed the intensity of light. 250, and then I'm going to upload it. See where the cursor is going. The cursor is going there. You see where the cursor is? That's the upload button. I'm going to hit, then watch what happens here to the LED. See the LED. Okay, you see it becomes more bright. Now let's put I'll put 100. Oh, sorry, where am I? Now let me put, I'm surprised I put 250 and it's showing dim. You put the entire thing 255. Oh, it's on, it's already on. Only it's showing, I don't know how to focus this. LED is already so bright. So now the finally 255, the final resolution. There it is. Yeah, it's totally bright. The camera effect is showing that it's not, but it's very bright now. So it can be off or on, depend on what value you put here. And we are running repeatedly the code here. Green light, we have declared the variables. So this is the way you can set up Arduino to show you analog signals, how they go. And analog means continuous, right? So first we did the digital, now today we have done analog, right? Yeah, man. So here it is, the breadboard, the LED, the resistor, which is 450 ohms resistor. I couldn't get 350, which is recommended. And, but it's better, safer to put a higher value than put low value, because the LED is endangered here. And this blue wire is connected to the shorter leg of the LED, which is negative. It goes to the ground, the negative. The longer leg of this LED is connected to the resistor, which goes to the red wire, which we are seeing there. This is connected to pin 10, right? And that's the Arduino itself down there, connected to the laptop there, the computer. And then the experiment, the code that we have written is this code, which runs there. I declared two variables there. Integer, it's an integer. It's not a float or it's not a string, it's a number. That's why I call it integer. And I given the value green pin, which is actually pin 10. I will initialize the values there. And here this code runs once only, and it's going to be an output because we are sending the signal into this Arduino. It's going to give an output. And down here where we repeatedly running the code, I written analog write, and in parentheses I put green pin, which I declared in the global variable up there, comma, and the light, the integer int light is 255, which is equivalent to 5 volts because we are taking up binary. Yeah, right. 2 4 1 2 4 0 1 2 4 8 16 30 32 64 128 256. But since we start counting from 0, we end up at 255, and that's what we have put up there, 255. Now you can less that figure to anything. You can tamper with it, and the LED will light accordingly in the breadboard here. Here is very bright, but the camera is showing a bit not. I don't know which angle I can put it for you to see. There's no way I can show it more than this, but it's on. It's on. You can see it's on. Yes, guys. So this experiment we have done today, and I'm gonna do more. And if you don't know what the Arduino is, you go to the first video where I defined it extensively. I told you it's that Mega 322 is a microcontroller. Micro, what do you understand by the word micro? Small controller. So it runs, it's both an open end and hardware and open end software, which you can configure to do anything, like running motors, Wi-Fi, switching off light, or writing messages to Twitter and stuff like that. But you need some other accessories to attach so that you can, for example, send a message to Twitter or even to your phone, smartphone. You can communicate through Arduino microcontroller. That small thing which is lit there, it's lighting there. I didn't put any delay here. I don't know what if you put a delay. What about, let me try something, guys. What about if I have to write another variable? I declare it light. No light is equal to 0. No, but it's the same thing. If you say no light and give it 0, it's the same thing as giving 0 there. And it will do the same thing. But you can do that if you want to put a delay, for example. I think it's possible to put a delay. Like here, if you declare this variable, I want to try something. I'm not very sure, guys. Let me try to write something, to be creative. What if I had to write analog? I'm not sure about this, but let's try something new here. Analog. Right. Analog, right. And I put the parentheses here. And write green, pin, comma. Let me call it anything like no light. And then up here, I declare another variable. I call it int. I'm writing, I'll show you. Int no light. This is purely something I'm just bringing from my head. I don't know whether it works this way. I put equals to 0. Okay. So then down here again, let me try to delay this thing just the way we did in the digital delay. I'm going to show you what I'm doing. Delay 500. I don't know what I'm doing the right thing. Microseconds. And then again delay here. This is purely creativity. Delay. Also say 250 microseconds. Okay, I want to see whether this thing can work, and I'll say no light. I don't know. I'm trying to do something that may not be possible to do. Let me put this. No, in this life you have to be creative, guys. Now I'm being creative here because this command may not be allowed to exist. But if it does, then that's good. Already it's flashing some major messages there. What the hell is coming over here now? Oh man. Oh, what happened here? I was doing this code here and these demonic forces. So I'm going to upload and see what happens. Then if something happens, I explain to you. Otherwise, I'm not very sure. Let me see. Yeah, surely I'm successful. See, it's blinking. It's delayed. I'm terribly intelligent here. I've done something which I guessed and it worked. See, the LED is blinking there with analog signals. So let me put it very fast. Today we are really having fun here. It worked, and it worked. The int you see, I said no light. So then I put it, initialized it there, then I ran it down here, then it's working. So let me just put this even less. I'm gonna put it even less. Let me put 50. Make it go really quick. And up there, I'm gonna show you, man. I hope I'm with you. I'm not lost you. No light, yes. Now delay. The main thing here is delay. Delay for 100 microseconds. See the new code that I've just put there. I've created this code from my head and it will really work. Okay, try to pick it up. Come on. Okay, you can see I created int no light equal to 0. Okay, then I wrote it down here. Let me show you. I wrote it down here. Delay, for example, 100 or 1,000, whatever microseconds, and delay again. Light on, green light, and this one, green, no light. I delayed, and the LED is blinking surely. I guessed it and it worked. So let's upload and see again. This is really good. There I've uploaded again. See, it might be faster now. Oh, it has compiled. See now. See how fast this thing is blinking. Because it's delaying less microseconds. On off, on off, on off, on off. You can even put any value you want to put. You see? So let me put now any value. Let me put delay 1000, 1000. I guessed it and it worked like a cinch, man. Okay, let me put 500. Okay, you see what I'm doing there with the delay thing that I've introduced there. Microsecond delay, 1000 microsecond delay, 500 microseconds for the Arduino. Then you see now it's blinking very fast there. Let me point my finger, maybe you are not seeing there. So let me upload this. I've changed the values and watch what happens to the LED. Watch what happens here where my finger is pointing. Watch. I don't know what you say. Okay, I put it like this. Watch the LED there. Now I'm going to upload. Okay, off, then on, off, on, off, on, off. Because on is longer, off is by half. On, off, on, off. Okay. Yeah, man. This is really fantastic. So guys, you have seen how we can program this Arduino thing, analogs. So, sorry, I've given you extra. Those are the things in the room, so don't mind. So we are done with this experiment, and this is all that I gotta show you today. Already you saw my face from before. I don't need to show it again. So thanks for watching. Now you can program a microcontroller digitally or analog, using analog or digital. I explained to you what analog is, from 0 volts to 5 volts. 0 is 0, 5 volts is equivalent to 255 because we are using binary. Okay, we are saying 0, 1, 2, 4, 8, 16, 32, 64, 128, 256. But since we start counting from 0, so we write there 255 as I wrote it there. 255 there. Or maybe I have to point it in my hand, in my finger there. 255 there. And everything the way I explained, you try, take your computers, try to repeat after me what I did, and see whether you can be able to perform this experiment. You can try various values, and you can delay the way I delayed, and see how it works. Okay guys, subscribe to my channel, please like and share, and stay tuned for more videos that are gonna come. Okay, yeah, so this is all for today. Bye from Victor Uya, YouTube. Those are the names I'm using, Victor Uya in YouTube. Okay, and actually those are my real names. So bye from me today from Nairobi, Kenya, Car West. What I'm putting up since I left India. I told you, nice place, very cool, very quiet, no interference, no noise. As you can hear, there's not much noise really here. Like in India, when I used to make a video, you used to hear the cooler is running there and all kinds of noise. Okay, bye from me, bye.